So the next question is looking at if the seagull, when's the ball going to hit 125? And so with standard form, you can set that equal to 125. It's interesting because if you had vertex form and set it equal to 125, you could do the same steps here as in the last question. But with standard form, you need to actually get 0 equals so that you could then use the quadratic formula. This is just kind of a visual showing what's happening. So if the ball is 120, or if the seagull's flying at 125, the ball is kind of going up, potentially hitting right here and then again here. But and so it's just kind of showing when is that parabola at 125. So if we move the 125 over, because we do have standard form, and we get something that we could basically sub into the quadratic formula, we realize that we can actually make the numbers smaller by kind of factoring out -5. And then if you realize -5 can't equal 0, you're really just trying to find out where t squared minus 8t plus 5 equals 0. And so when you use the quadratic formula, that just makes your numbers a little bit smaller, and a would be 1, b would be -8, and c would be 5. Visually, what this is showing is when this parabola with the t squared minus 8t plus 5 is equal to 0, it's actually going to happen at the same time as when this parabola is 125. And so it's just kind of neat to think about the connection between what's t squared minus 8t plus 5. That has nothing to do with a ball being launched in the air. It's opening up. But it has the same zeros as when this guy hits 125. And so I just wanted to show that from Desmos. So if we use the quadratic formula, we can sub in -8 plus minus -8 squared minus 4 times a times 5 over 2a. If you use -5, 40, and -25, you get the same answers, but the numbers are just a little bit bigger. So you've got 8 plus minus 64 minus 20, which is 8 plus or minus 44 over 2. Root 44 is actually 2 root 11, root 4 root 11. And then the 2's actually reduced nicely to 4 plus minus root 11. And so that's, in fact, what the decimal of 4 plus root 11 and 4 minus root 11, which is 0.683. Okay. I think somebody rounded wrong. It might have been me, 0.6824. I'd have a hard time thinking Desmos got that wrong, so I might have rounded off a little bit wrong. Okay, and so the seagull and the poor bird was hit again. It probably went away from the model though. If you just wanted to find out if the ball was going to hit the seagull, it might not make sense to do the whole quadratic formula. And also, if you just wanted to figure out what this guy under the square root is, just to make these steps a little bit shorter, it might make sense just to look at something called the discriminant. The discriminant is the thing that's just under the square root, and if we know b squared minus 4ac was bigger than 0, we know that there are 2 roots. You can't square root a negative, so this is what it's kind of like. Then you'd have plus minus something. If it equaled 0, there'd only be 1, because there is 1 root, because b squared minus 4ac be 0, and plus minus 0 is nothing, is the same thing. And b squared minus 4ac, if it was less than 0, you'd kind of have to stop, and there'd be no roots because you can't square root the negative. And so if you get a question like this, which we saw before, is it possible you could just calculate so that realize that okay, break even means profit 0, and then to solve this equation for 0 equals, we could just calculate the discriminant and get -9 and see it's not possible. We're never going to get zeros here because the square root of a negative is not going to give you anything, and that saves you some work that you don't need to do in the quadratic formula. And so you notice if you graph this in Desmos, you actually see that it'll never hit 0. It's got that y-intercept of -15. It's opening down, but it doesn't go up high enough. Last question, point of intersection of the functions of f of x and g of x. So we're going to find out when these two functions equal each other. So now you have a situation where you've got the roots of a quadratic equaling a line, which is not much different than if a quadratic equaled a number. And so we are going to subtract the 2x and the 4 from both sides. And so we really just have 0 equals x squared plus 4x. Now you can ask yourself, quadratic formula, sure. It does factor kind of nicely, just a common factor. And the zeros are then x equals 0 and x equals negative 4. And so those are going to be the x values of the point of intersections. To get the y values, you can just go sub in the inputs of 0 and negative 4. So you get 0, when you sub in 0, you get 4. And when you sub in negative 4, you get negative 4. And I'd probably sub them, you could sub them into both to check, but I'd probably just sub them into the linear equation. And so you notice if you graph them in Desmos, f of x is the straight line, the red graph here, and g of x is the quadratic, and they're hitting each other at these 2 points. Notice that the solving only gives you the x values. You actually have to do a little bit more work to find the y values. Okay, there's a bunch of homework there, but and it's kind of like related into the skills. And so the skills are kind of divided up in terms of like the different kind of solving questions. And so that's why it's broken up. But so it's good to like practice some of these skills, but all of these questions are solving quadratics.